Hi engineers. Ever heard of a coding challenge called Happy Number? Interviewers like it, and not everyone can pass and explain it. So let's crack it today. Happy Number is a classic logic problem. First, let's break it down in plain English. You take any positive number. You split it into digits, square each digit, and add them up. Then you repeat that process on the new number. If you eventually reach 1, the number is happy. If you start repeating numbers and never hit 1, it's unhappy. Let's set up 3 example inputs right now. We create a variable n1 and set it to 19. Then we create n2 and set it to 2. And we create n3 and set it to 7. Now, let's start with a simple beginner-friendly approach that is easy to explain out loud. We will detect loops using a set. We will keep generating the next number. If we ever see the same number again, that means we are in a cycle, so it is not happy. If we hit 1, it is happy. Here's how it works. We create a helper function named sum of squares that takes one parameter called n. Inside the function, we declare a variable sum and set it to 0. Then we creating a while loop where while n is greater than 0, we take the last digit with modulo 10, add digit times digit to the sum, then drop the last digit by dividing by 10 and taking the integer part. When the loop finishes, we return the sum. We create a function named isHappySet that takes one parameter called n. Inside the function, we create a set named scene. We start a loop. While n is not equal to 1 and scene does not contain n, we add n to scene, then set n to sum of squares of n. When the loop ends, we return whether n equals 1. Let's test it. We write a console log of isHappySet of n1, then a console log of isHappySet of n2, and a console log of isHappySet of n3. When we run it in the terminal, we get true for 19, false for 2, and true for 7. Perfect. Complexity for this version. Time is bounded by the cycle behavior. Space is O of k for storing scene numbers. Now here comes the cleaner constant space solution that interviewers like the most. We use Floyd cycle detection with 2 pointers. One pointer moves 1 step at a time, the other moves 2 steps. If the fast pointer reaches 1, the number is happy. If slow and fast become equal before hitting 1, we found a cycle, and it is not happy. Let's code the optimized version. We create a function named isHappyFloyd that takes n. First, we set slow to sum of squares of n. We set fast to sum of squares of n. We start a loop. While fast is not equal to 1 and slow is not equal to fast, we move slow to the sum of squares of slow, and we move fast to the sum of squares of fast. When the loop ends, we return whether fast equals 1. Let's test the optimized version the same way. We write a console log of isHappyFloyd of n1, then a console log of isHappyFloyd of n2, and a console log of isHappyFloyd of n3. When we run it in the terminal, we get true for 19, false for 2, and true for 7. Complexity for this version. Time is bounded by the same process. Space is O of 1. Here are the top 3 most important interview tips for the happy number problem, the ones that actually move the needle from good to strong higher. First, drop the cycle detection insight immediately. As soon as you finish reading the problem, say out loud. This will either reach 1 or get stuck in a cycle, so the key is detecting the loop. We can use a hash set for scene numbers or Floyd's tortoise and hare if we want constant space. Interviewers light up the moment they hear cycle detection because it shows pattern recognition. Second, trace the example 19 step by step verbally while coding. While typing the digit squaring loop, narrate. Let's take 19. 1 squared is 1, 9 squared is 81, sum 82. 8 squared 64 plus 4 equals 68. This proves you deeply understand the process, not just copying code, and fills silence naturally. Third, offer the magic number 4 optimization at the end. After your set solution works, casually say, fun fact, every unhappy number eventually reaches 4. So we could simplify to, while n is not 1 and n is not 4, and skip the set entirely. Shows you went beyond the standard solution and know the math trivia. Huge differentiator. Master these 3, and happy number becomes an automatic strong yes signal. Now you're 1% smarter. The cheat code is consistency, so keep boosting your brain. Make it your daily routine, and you will nail your next interview. Same rhythm tomorrow at Code Crack Interviews.